I'm Casen Thompson, and I'm a senior here at Utah State. I'm majoring in mathematics with a minor in electrical engineering.
I'm Sam Morrill. I'm a junior. I'm majoring in electrical engineering with a minor in mathematics.
This is our ECE 3710 final project. We built a semi-portable game machine with 3 different games: Pong, Tic Tac Toe, and Conway's Game of Life. I mainly worked on the communication with our 16x16 LED display and the LCD screen. I also wrote the Game of Life and Tic Tac Toe.
I programmed Pong, the joystick communications, including the ADC, and I also did the hardware assembly and wiring. We hope you enjoy our presentation.
Here's a short demonstration of our system. We'll switch the on button and press the green button to start. Then we can cycle through the Game of Life, Tic-Tac-Toe, and Pong. Here we'll play a quick game of Pong just to demonstrate the physics, which aren't perfect, but it has its basic functions. We'll switch over to Game of Life. We'll throw a little box in here, and then start. As it disappears, we can go into pause to reset or draw some more. We'll exit that and go to Tic-Tac-Toe. Here we can place tiles, move, and throw some circles down and all that. And I've lost against myself. X wins, and then I'll clear the board to play again. You can exit and go back to the main menus.
Let's go over all of the input and output devices that we used in our project and compare them with what we plan to use in our proposal. At the time of writing our proposal, we weren't sure what size of LED display we were going to use. In the end, we decided to use 4 of our 8x8 LED displays, creating a larger 16x16 LED grid. The LED displays are each controlled by a MAX 7219 chip, which could store data and perform the required repeated actions to keep the correct LEDs turned on, meaning that we just have to send the chips the commands to turn on and off the LEDs we want to turn on and off. In our proposal, we stated that we would use the LCD screen to display instructions and game results. We fully implemented this in our project, and the LCD screen will give the user instructions and declare who won the games throughout operation. For the user input, we have 3 push buttons and 2 joysticks. The push buttons are primarily used to enter and exit games, and in general, green means start, yellow means pause, and red means return to the main menu. The joysticks are used to navigate the menu and to play the various games. The joysticks give out 2 analog signals, one for horizontal position and one for vertical position. We then use the ADC to tell us exactly the coordinate position of the joysticks. The joysticks also have the ability to be pushed down like buttons, allowing for further user control. Our proposal talks about using the keypad to control a few games. This was partially because we were uncertain if we were using the joysticks at that point and wanted a few alternate plans for user input. We ended up removing plans for the keypad when we realized that almost all of its functionality could be replaced by the joysticks and buttons, meaning that the keypad would just increase complexity without adding any capabilities to the machine.
The system is powered by a 12-volt supply, complete with a power switch. The 12 volts is converted to 5 volts using a buck converter. The 5-volt supply powers the microcontroller, LCD, and dot matrix displays. The joysticks are connected to the microcontroller's 3.3-volt supply, which is the reference voltage for the analog to digital converter, which is used to read in the user input. Here we have the layout for the GPIO pins we used in this project. For all the buttons, we used the GPIO C ports 4 through 7 and 11, configured as input with pull-up resistors. For the joystick input, we used the GPIO C 0 through 3 pins, which can be configured to be the ADC channels 1 through 4. For the LCD output, we used the same pins that we used in a previous lab, which was GPIO B 0 through 5. Each LED matrices had a set of 3 pins to send data out to the display: data in, chip select, and clock. These pins were configured to be push-pull.
Next, we'll go over the software that we implemented onto our project. We built a main menu where the user could select between one of 3 games: Conway's Game of Life, Tic Tac Toe, or Pong. In our proposal, we just mentioned using the buttons to toggle between our games, and so this menu system is an expansion from that. Our project is a state machine, where each game and the main menu is their own state, and any game could return back to the main menu state. In our proposal, we discussed a few games that didn't make it into our final project: Snake, and a setting that could display fun patterns. We didn't implement these, as the goal in our proposal was just to implement a majority of our listed games, which we achieved. In the game of life, the user can use the left joystick to move a blinking cursor around the grid to activate tiles. Pressing the joystick button will toggle between making tiles alive or dead. Once the user is ready, they can press the green button to start the game of life. The game will then run until the user presses the yellow button to return to the user input phase. If the user presses the red button at any time, the machine will return to the main menu. In Tic-Tac-Toe, each X and O takes up a 4x4 space, allowing for a large Tic-Tac-Toe grid to fit on our display. When the game starts, the first player is prompted by the LCD to place an X, using a left joystick to move to the desired position, and then pressing on the joystick button to confirm. The second player can then place an O by moving with the right joystick. Once either a player has won or there is a tie, the LCD screen declares the winner. After a few seconds, the board is cleared and the game starts over. Pressing the red button during any player's turn will return back to the main menu.
In Pong, a player presses down the joystick to start the round. Each player controls a paddle which is used to bounce the ball to the other player. During the round, a yellow button press will pause the game, a green press resumes the game, and a red press will exit the game at any point. During the game, the speed of the ball and paddles increases slightly each time the ball hits a paddle. A player scores when their opponent fails to hit the ball back. The scores are displayed on the LCD. The game ends when a player scores 5 points. Here is another demonstration of the game of life.
That concludes this presentation. Thank you for watching our final project submission, and thank you, Dr. Phelps, for making this a wonderful class. Bye-bye.
Thanks.